For our presentation, we have decided to implement a series of microphones in order to record and track traffic on busy city streets. Noise pollution is an often overlooked issue in our man-made environments, especially in our larger cities. Noise pollution in cities is caused mostly by vehicle traffic, although some noise pollution is generated by other sources. We decided to focus on vehicles as they tend to be far louder and far more distractive, especially unmuffled vehicles and motorcycles. On our larger scale, our proposed network would be able to track noise levels and determine the areas with heaviest noise pollution. If utilized across the city, it would be possible to determine the areas of most traffic and noise, and could be corrected from there. The information would be sent to a common receiver per area that could track different noise levels and even work with traffic lights to alter traffic patterns and reduce noise. In a smaller scale, we have started to design a system of multiple microphones that transmits information to a common receiver.
The sound sensor was constructed by connecting a J60 microphone to a voltage divider, which is then fed into an amplifier that has been an implemented low-pass filter to remove high frequencies. The amplifier was implemented to increase the gain so that the output is large enough to be noticed.
The Arduino The analog signal from the microphone is then sent into the Arduino, where it's sampled 256 times. The Arduino normally samples at a rate that's too slow for our needs when using the analog read functionality, so we're manually going in to the @mega chip and using an interrupt-driven approach. These 256 samples are then fed into a fast Hartley transform that is windowed and reordered, and then packaged to be sent out to the transmitter. Currently, the sampling functionality has not yet been fully implemented, but the transmitter can be demonstrated using an example string. Using a simple serial application, the string "Hello World" is sent to the Arduino and is then sent to the transmitter. This transmitted code can be seen in blue.
With machine learning and neural network, we can let the computer try to solve the problem itself. A neural network is a function that learns the expected output for a given input from a training dataset. For example, in this case, to build a neural network that recognizes sound wave produced by vehicle, we train the neural network with a lot of sample of each sensor in the presence of vehicle. The resulting network as a function that takes sound wave from the microphone as input and output the state that the car is present.